All right, so we're going to talk about the tangent function today. And a good portion of what we're going to talk about is going to be the graph. And so there are a whole lot of these AP pre-calculus standards we're going to go over today. Like this is a very dense lesson. But you're gonna be fine. And we're actually gonna learn everything today and practice, and then tomorrow is just gonna be a practice day on the tangent graph. And so we first talked about tangent of an angle in lesson 6.2, and all of these things were in the lesson. And then we didn't do anything else with tangent. We just focused on sine and cosine. But we did learn that if you want to find the tangent of an angle, you can divide the sine by the cosine of that same angle, and it gives it to you. We also learned the tangent of the angle matches the slope of the terminal ray. So whatever the slope is of this, it is the same as the tangent of the angle, which is kind of cool. And then we also learned that either on the unit circle or on any circle, that you can find the tangent of an angle by doing the y divided by the x coordinate, or a lot of times it's y times the reciprocal of the x coordinate. So we are going to do those things today. And we're also going to look at the graph of the tangent today. All right, now I'm going to be kind of flipping to a page I have on here that you don't have, just to kind of show you how the tangent comes about. And then if you look at the next page, you can see what the tangent graph looks like, but I don't want to ruin it for you. So we think of the tangent as the slope. The tangent of where the graph or where the angle is 0 is going to be a horizontal line. What is the slope of a horizontal line? 0. So I'm going to do a little graph over here. Like I said, you don't have to worry about this. So the tangent of 0 is 0. All right. And then as we go up, is that going to be a positive or a negative slope as we go up? Positive, and it's going to get steeper and steeper and steeper and steeper. And so the tangent of pi over 4. So it's like a 45-degree angle. What would the tangent of that line, what would the slope of that line be if you drew one at a 45-degree angle? What? So like, for example, let's pretend this is exactly 90 degrees here, and we drew, what would the slope of that line be? 1. So pi over 4 is 1. This is going to be here. This is going to be here. And then it's just going to get steeper and steeper and steeper and steeper as we go up. And then what about the tangent at pi over 2? This line right here. What would the slope of that line be? A vertical line, undefined. Good. So the value of the tangent of pi over 2, there is no value. It's an undefined value. All right. So then we're going to keep going around the circle. So then I have the slope of like something like that. Is that going to be a positive slope or a negative slope? Negative. Super, super steep negative. So we're going to have negative, 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 negative. And then it's going to come around. And then it's going to be -1. And it's going to be that. And then what about the slope at pi? 0. It's a horizontal. We're thinking of slope. The slope of a horizontal line is 0. So back at pi, we're 0 again. All right. And then we're going to keep going around the circle. And here, is that going to be a positive or a negative slope? Positive. So it's going to repeat that same thing all over again, because I can draw this all the way across. I can draw this all the way across. And so you're going to keep seeing those same values again for the tangent, because the slopes match. until you get like super, super, super steep again. All right, so now let's look at the tangent graph. All right, so then when we get to 3 pi over 2, we're at undefined again, and then we just see those same things again until we get back to 0 at 2 pi. All right, and so each time the terminal rate is vertical, the slopes are undefined. They're either approaching positive infinity or negative infinity. When we graph the tangent function, this means we'll see vertical asymptotes. When theta is equal to pi over 2 or 3 pi over 2. And then each half turn around the circle, we're going to get another vertical asymptote. So this is going to just repeat that pattern over and over and over again. All right, so what you see there is the tangent graph is actually a little bit more than half periods of tangent. So this is going to be f of theta equals tangent of theta. Right. And then this right here is 1 period of tangent. All right, so this is what a tangent curve looks like. And it just repeats that same period over and over and over again. How long is that period? It's a half on the left and a half on the right. So it's going to be pi. So the length of a period of tangent is going to be the distance in between the vertical asymptotes. And we're going to write that another time. Okay, now I'm going to write some things on here that Brian Passwater didn't write because some of it's kind of weird and he wouldn't be weird, I don't think. Maybe. But I like to tell my students that tangent is a happy graph. It's always going up. You're never falling when you're drawing a tangent graph. So always increasing. Except at the vertical asymptotes. There just nothing is there at the vertical asymptote. So can you think of something that would make tangent sad? A reflection on the x-axis or the theta axis. And so that's going to be a negative, and if we look at this guy right here, it's going to be a negative a. Oops. So negative a makes tangent sad. All right. Now on sine and cosine, what did a kind of correspond to? The absolute value of a. What did that correspond to? The amplitude. And so what was like the official definition of amplitude? Very good. Distance from the midline to the max. So looking at the way tangent is tangent going to have an amplitude? No, there is no max. And there is no min. So this is going to keep going up and up and up, and this is going to keep going down and down and down. So tangent does not have an amplitude. All right. And then one more thing we're going to jot down that he may have in somewhere in all these words that I'm not sure if I saw it here or somewhere else, but a tangent curve changes from concave down to concave up at the midline. So tangent changes from concave down to concave up at the midline, which is going to be D. So that also means that's a point of inflection. I didn't talk about that last period, but okay. So in this box, we have this generic form of the tangent graph where A, B, C, and D are all numbers in a real function. And the vertical dilation of the graph of tangent is by a factor of the absolute value of A, but A is not going to represent amplitude at all. The period is going to be the absolute value of pi divided by B. So do you remember the period of sine and cosine? It was 2 pi divided by B. So because the period of the original tangent is shorter, it's pi, when we do this to find the period, we just do pi divided by B. All right, the phase shift works exactly the same way as it did on sine and cosine. So it's just the rules for transformation. So it's going to be negative C units for the horizontal translation. And then vertical translation works exactly the same way as well. It's going to be D units. That's also going to give you the midline. Okay, I've said so many words. It's okay. Let's do some examples. So we start off kind of with a tough one. The part of this that's tough is finding A, and I really racked my brain trying to find a good way to find A, and this is the only thing I could come up with. So for example 1, we have a portion of F, which is going to be 3 periods of this tangent graph, and so we're going to figure out what A, B, and D are. So let's start with B. So try to remember that the period of a tangent is going to be the distance between vertical asymptotes. So what is the period of this guy? 1/2 pi, right? So pi over 4 on the left, pi over 4 on the right, you add those together, it's going to be 1/2 pi or pi over 2. Now I typically do that, like if it's 0, you can just double that value, but sometimes it's shifted around and you might want to do this, but you can always subtract. So subtract the right one from the right one minus the left one, and that's going to give you the period no matter where. Okay, now we're going to use this right here to figure out what B is. So the period is going to be equal to pi divided by B. So pi over 2 is going to equal pi divided by B. Well, that's kind of obvious. The B is just going to be 2. It's not always that obvious. Sometimes you have to do some multiplication. All right, D is going to be the vertical translation or the midline. So where is that here? 0. All right, and I'm going to come up in the space beside the graph to find A because it's the tough one. Okay, so we're going to find a point on the graph, and I don't think we can use a 0. I haven't tried it that way. I don't think it would work because you're just always going to get 0 equals 0. So use a point on the graph that's not a 0. All right, so I'm going to use that point right there. And that's going to fall halfway in between the 0 and the asymptote. So that's going to fall at pi over 8. So our point we're going to use is pi over 8, 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. right? And then what we're going to do is plug in to our formula. Plug into f. So in the place of f of x, I'm going to put 1. A is what we're looking for. In the place of b, we are going to put 2 because we found that. And then in the place of x, we're going to put pi over 8. And then in this case, d is 0. All right, and then we're going to solve this for a. All right, so we want to take 2 and multiply it by pi over 8, and that's going to give us pi over 4. Do you guys know the slope of the line at pi over 4? Looking at your unit circle? We can do this 2 ways. You can just know what that slope is. Slope of this line right here. What do y'all think? It's 1. Or you can use the unit circle and do the y divided by the x. So either way, the tangent of pi over 4 is just 1. So that means, in this case, a is 1. Okay, that's kind of crazy. We're going to do another one in a second. It's actually one that's not necessary to do it to answer the question, but I want to practice it with you one more time. Actually, let's just go ahead and do that one. And we'll flip around what's fresh on your mind. Let's go ahead and do example 4, then we'll come back. So we did a ton of these with sine and cosine, where we had the graph and you matched it with this equation. This is going to be slightly simpler because we're not having to decide if it's sine or cosine. We know it's tangent, so that's a little bit easier. So first thing I'm going to do is figure out the midline. So what do y'all think? Can you tell? Go ahead. It's -2. It's where the graph is changing from concave down to concave up. And so we can eliminate a couple of these answer choices. All right, so how are we going to decide between if we have x over 2 or if we have 2x? We're going to look at the period. We're going to figure out what b is. So what is the period of this graph? Yes. All right, and for tangent, we can say that the period is equal to pi over the absolute value of b. So our period is 2 pi. It should be equal to pi over b. So we'll switch places. So b is 1/2. So that's going to make our answer A. Now, like I said, we're gonna do some unnecessary work just so we can practice actually finding that number in front of tangent one more time. Okay, so I'm gonna do it over here. We're gonna be finding A. So we're gonna take a point on the graph. Well, shoot. I said it's not a 0. I guess maybe I should have said not on the midline. All right, so our point this time is going to be pi over 2 -1. I'm going to put -1 in for y, or f of x, and then it's going to be a tangent of x, which is pi over 2, over 2 minus 2. So all I did is I took this guy that we said was our answer, and I put everything in except for a is what we're looking for. So what do you get when you take half of pi over 2? Yes. Do you guys know what the tangent of pi over 4 is? I want you to. It's the slope of this line. Just 1. All And then when I add that to, I'm going to get that a is 1. And that's why there's not a number in front of our tangent, because it's an understood 1. All right. You're going to get better at that. It's just going to take some time. Okay, we're going to go back and do example 2. Now, I don't feel like we practiced enough of these with sine and cosine. They really like to put these questions on the ACT where they give you the equation of the function, the algebraic expression for it, and then ask you what the period is. And a lot of times it's tangent, so that's good. But you should be able to just look at the equation and find the period for tangent by doing pi over the absolute value of b. If it was sine or cosine, you would do 2 pi divided by that b. And b is always what's being multiplied by the x. So the period is just going to be pi divided by 2. All right, any questions on that? Okay, and then example 3 on Brian Passwater doesn't make many mistakes, and I didn't catch it. I printed off this worksheet. It is editable. But all of these should be, is an integer. It can't just be any constant. Brian Passwater is kind of my hero. He's a really good teacher. Okay, and so we talked about this kind of at the beginning that those vertical asymptotes repeat every period. So every time you add a period, you get another vertical asymptote, and add a period, and you get another vertical asymptote. So we want to figure out which one of these choices represents all of the vertical asymptotes in the whole problem, like forever. So what we want to do is figure out like where one of them is. And so on the original tangent graph, one that hasn't been transformed in any way, we have a vertical asymptote at pi over 2. So I'm going to jot that down. So just y equals tangent of x has a vertical asymptote at pi over 2. But if this one has any kind of horizontal change, that vertical asymptote is going to be moved. So it could be shifted, it could be dilated around. And what changes that is this part right here. Anything that's in the parentheses. So what we're going to do, and we did something similar to this, is we're going to take x over 3, and we're going to set it equal to pi over 2. And that's going to give us our new vertical asymptote. And so if you want to remind yourself where that came from, you can draw a little arrow. Right, and then what we need to do is just solve this for x. And you can cross multiply, or you might be able to just do it in your head. But x is going to be 3 pi over 2. And there's only one of those choices, but it's possible we're still going to need to find like another type of problem. There might be 2 of those. So let's talk about where this 3 pi k is coming from. Where do you guys think it's coming from? K is any integer. So k represents 1, 2, 3, 4, any negative, any integer. Where's the 3 pi coming from? Any ideas? How often on this graph are you going to get a vertical asymptote? Every period. So every period there's a vertical asymptote. So that needs to represent the period. So let's just make sure it does. So the period is going to be pi divided by b. pi divided by the coefficient of x. So if you have x over 3, what is the coefficient of x? What would you multiply x by to get x over 3? 1/3. Good job. Now we know we don't ever leave a fraction inside of a fraction, so we would multiply by the reciprocal, and we get that the period is 3 pi. And so it is right for that particular problem. No, this is a lot of stuff in one day. You guys are doing great. All right, the last part is going to be the easy stuff we've done the whole day, because we've already done it a little bit. Okay, this is where your unit circle is going to come in handy. And so whenever we are finding these on the unit circle, anytime we want to find the tangent of an angle, we're going to do the y-coordinate either divided by x or times the reciprocal of x. And try to remember that it also is going to match the slope of the line at that angle, if you want to. That's helpful. All right, so when I do pi over 6, we go to our unit circle, take the y-coordinate at pi over 6, which is 1/2, and multiply it by the reciprocal of the x-coordinate. Those 2's cancel out, and we're going to leave it as 1 over the square root of 3. Now, one thing I like about AP pre-calculus compared to pre-calculus I've taught in the past is we can leave that radical in the denominator and it doesn't matter. Calculus, it also doesn't matter. Just leave it down there. There's so many other things to worry about. We're not going to worry about a radical in the denominator. It's fine. Okay. And then let's find the tangent in pi over 4. Do you guys already know the tangent in pi over 4? Yes. If you don't, it's fine. You take the y-coordinate and you multiply it by the reciprocal of the x-coordinate, and everything cancels out, and you're just left with 1. All right. And then pi over 3, we're going to take the y and multiply it by the reciprocal of the x. All right. So for the angles, the special angles that are slanted, that lie inside the quadrants, these are the 3 answers you're going to get for tangent. It's either going to be these 3 or the negative versions of those 3. But that's always going to happen for a tangent inside of the unit circle, not the horizontal and vertical angles. All right, so let's look at 5 pi over 6. We're going to take the y and multiply it by the reciprocal of the x. All right, our 2's cancel out, and a positive times a negative is a negative. All right, so all of these pi over 6 angles, the tangent is either going to be 1 over the square root of 3 or negative 1 over the square root of 3, every one of them. What do you guys think about the tangent of 4 pi over 3? If I'm looking at these 3 options, which one do you think is going to match the most? The other pi over 3. It could be positive, it could be negative. Let's figure it out. So it's going to be some kind of square root of 3. And so when I do 4 pi over 3, it's going to be negative square root of 3 over 2 times negative 2 over 1. What's a negative times a negative? Positive. All right, and then for pi over 4, all of those pi over 4 angles have either a slope of 1 or negative 1. And so if you're looking at your unit circle and you kind of like hold your pencil at that line, would that be a positive or a negative slope? A 7 pi over 4 would be negative. Or you could do the math. All right, and then finally we have the quadrant angles, the angles that the slope is either 0 or undefined, either horizontal or undefined. Or you could do the math. And the slope, I mean, they specifically speak about the slope in the standard, so I feel like they're going to ask questions using the slope, but we can do the unit circle if you want to. So for a 3 pi over 2, that's a vertical angle, so it's definitely going to be undefined. But using the unit circle, we would do the y divided by 0. And anytime you divide by 0, the answer is undefined because you cannot divide by 0. All right, for pi, you can either think of it as a horizontal angle with a slope of 0, or you can do the math where you do 0 divided by -1 and 0 divided by everything except 0, 0. What do you guys think about tangent pi over 2? Undefined. Good job. All right, I really feel like I said a million words today. Do you all have questions on any of this tangent stuff?